Hello, everyone. Welcome, and thank you for joining us today. My name is Fletcher Nelson, I'm Technical Evangelist with Alexa Voice Service, and today we're going to be presenting a webinar on Alexa Multi-Room Music. Before I introduce our speaker, a couple quick housekeeping items. We are recording this webinar, and we'll send a follow-up email to all registrants. So if you need to review the material, look for that. And if you have any questions, don't save them for the end. Please go ahead and type them into that chat box at the bottom of the webinar, and we'll be answering those live after we finish the talk. So without further ado, let me introduce our speaker for today, David Frerichs, a serial innovator with 25 years of music, virtual reality, and connected devices under his belt. He holds a Bachelor of Science degree in Computer Engineering from the University of Illinois at Urbana-Champaign. He joins us today as Principal Solutions Engineer on the Amazon Alexa Voice Service team to present Alexa Multi-Room Music. And what is Alexa Multi-Room Music? David, take it away.
Cool. Thanks, Fletch. It's really great to have the opportunity to talk to everybody and share with you this technology that we've been working on for quite some time, and we're really excited that it's now making inroads beyond Echo devices and out into Alexa voice service devices. So that is the Alexa multi-room music technology. So, before we kind of jump into the details, let's actually make sure that we know what it is that we're talking about here. So Alexa multi-room music is simply the ability for a user who has multiple Alexa-enabled devices in their home to be able to group them together as either one big group or as multiple different groups that may overlap or may not overlap, and then say to Alexa that they want to play music from any Alexa music service provider onto that target group. So for example, if you wanted to play music on all of the devices in your home, you would make a group with calling it Everywhere, for example. And then you would just say, Alexa, play jazz music everywhere, and it would play on all of the devices in your room that are in your home that are within that Everywhere group. So it's a really attractive feature for consumers because, as we know, when you have multiple speakers around the house, you want to be able to have them all working together, and that's exactly what Alexa multi-room music allows you to do. So with that kind of introduction on the actual capability itself, what's the goal of what we're doing here today? Well, we want to talk to you as developers to give you a picture of why MRM is important to your customers, that is, people who are using Alexa-enabled devices. We're going to give you some detail on how the technology works and how to integrate it. Platform considerations that you need to keep in mind when you are actually adding this feature to your product. And then how do you go about integrating it and then getting it out the door? So hopefully this will be a helpful session. And as Fletch said, if you have questions in the middle of it, please make sure you type those questions into the bar on the bottom, and we'll answer those live at the end. So let's start off by talking about this technology, right? MRM, multi-room music, why is it important? Bottom line, consumers are expecting it. It's a capability that we released on Echo family products in August of 2017. And since then, people who use Alexa have come to expect it when they are using their Alexa-enabled products. And so when they encounter a product that is from another developer that does not have that capability, it actually is something that they are missing. They're saying, hey, where is this? And that leads to, of course, as we're seeing here on the slide, maybe the fact that the product may not be getting the reviews that you might hope for. So as a technology, it is something that is very important to make sure that you include when you're doing the integration of Alexa into it. So when we think about multi-room music, there are a number of different technologies that could actually go under that label. Now, our focus here today is on the Alexa multi-room music technology. But as you may have heard, or you might even have within your own systems, there are other multi-room music technologies out there. You think about like Apple's AirPlay or other things along these lines. But what we're talking about here in particular are solutions that device makers may have put into their ecosystem And some of them have been doing this for a number of years because obviously, Alexa hasn't been around for all that long. And so there are actually the ability of some device makers to create groups of their own solutions that uses their own multi-room music capability. And that is not what we're talking about today, but I wanted to call it out in particular because if you did have a technology along those lines and you were wanting to enable that through Alexa, you use something called our Cloud Connected Speaker API. And that is something that allows you to, using voice control, may actually control these groups in the same way that someone might control an Alexa multi-room music group. Now, the only hitch here is that those, since they are not using the same protocol and infrastructure on the synchronization side that is used by Alexa multi-room music, they can't be grouped together with the same devices into a, let's call it a bigger group, but you can actually have these things coexist within the same network. So it's not mutually exclusive, just means that if that's the technology that you have, we have one path for you, and that's the connected speaker API that's done through skills interfaces. And then on the flip side, what we're focusing on today is the Alexa multi-room music technology, which is a native function that gets embedded into your devices directly and interacts directly with the Alexa cloud in a way that allows you to group these devices together, not only with your own products, but with all Echo products and even other third-party products that use the same system. So it's a nice interoperable capability that we've brought to the table. So let's kind of get a baseline, and this may seem like, Alexa 101 for a lot of people, and it is, but it's helpful to kind of do a build here to understand what it is that we're talking about when we are trying to do this kind of grouping of devices and then what we call targeting. So the typical device interaction that somebody has with Alexa is that you have a device, and that device has microphones and a speaker on that same device, and you simply say to it, and this is a nice little iconographic representation of me apparently, you say, Alexa, play Despacito. And when you say that to Alexa, it goes up to the cloud, and Alexa resolves that command. The command comes back down to the device, and the device itself then goes out to the assigned music service provider. And then that music service provider, or MSP as we're calling it here on this slide, then streams the content down to the device, and it plays back on that same device. And so that's the typical device interaction that somebody has when they're wanting to play music through Alexa. Now, one thing that many people may not be aware of, although the awareness is growing, is that if you have two Alexa devices in the same home, or on the same account, I should even say, they don't even have to technically be in the same home, what you can say is that, Alexa, play dubstep in the living room, and if living room is assigned to a specific device that you have attached to Alexa, then that music request doesn't come back to the actual device that you were talking to, but instead that request gets routed out and ends up down on the device named living room. And it's that device that goes out, gets the content from the music service provider, and starts playing it on its speaker. And that's something that you can refer to by calling Alexa targeted music playback. Simply said, you are making a request on one Alexa device, and on that first Alexa device, the request is processed, sent up to Alexa. But when Alexa understands the request, it actually will send that action or that directive not back down to the device that did the audio input, but will send the directive out to the named device, in this case, living room, that will then start to take action and start to do playback. This kind of targeted interaction, by the way, is something that is fundamental to the direction that we're going with Alexa, that is to enable a more ambient experience, where Alexa really isn't something that lives in the box necessarily, but Alexa is the ambient intelligence that then creates a consistent experience across your entire home environment. And this is just one example of how that works. Now, let's extend that idea. You already hopefully are familiar with now the concept of targeted playback. That is to say, I can make a request on one device and then have the music play back on a different device. Multi-room music as a technology simply extends that same concept. And what it does is that you first create a group of devices. On this slide here, the group is the number of devices here on the side. Let's say the 3 devices that are coming out called AVS client, right, over on the right-hand side of the slide. And those are all created into a group using the Alexa companion app called Downstairs. Now, when the user says, Alexa, play trap music downstairs, what will happen is that when the request gets sent up to Alexa, Alexa says, aha, I know that downstairs isn't a single device, but rather it is a group of devices that are all supposed to work together in the Alexa multi-room music fashion to play music synchronously across each other. Alexa will then pick one of those devices as the sender device and give a specific instruction to that sender device, which may be the one that you spoke to, may be a completely different one. It doesn't matter, actually. This diagram shows it that the speaker happens to be speaking to the one that's the sender, but it actually is not necessarily that same device. It could be any of the devices in the group. And then that one gets a directive to say, hey, you go to the MSP, you get the content, please. All of the rest of the devices in that group then receive an instruction that says, hey, you're supposed to be playing this content as well, but instead of going to get it from the music service provider, we want you to go get it from the actual sending device, which is also on the same network that you're on, which is, by the way, a fundamental requirement. We'll talk about that in a moment. But it's going, all of those devices are going and pulling that stream from that sender device. And then because all of these devices, when the group was formed, created a common time base, that is to say they all have a very, very accurate shared clock, then they can all play it back in perfect synchronization. And just to give you an idea of how well this is, when we do room level sync, we're synchronizing down to 5,000 microseconds. When we're actually doing left-right stereo pair synchronization, we actually even bring that down even further to 150 microseconds. And so those are the tolerances that we put in place to make sure that the user experience is as good as it possibly can be, so they are actually hearing this content at the same time across all of their devices. And one of the reasons why we did this as Amazon and created this Alexa multi-room music system instead of using another off-the-shelf solution, because most people on the call here are probably aware of the fact that there are a number of different ways of doing this that are in the market today. The key thing that we found is that when Alexa is operating in a consumer's environment, when our customers are using it, what ends up happening is that they're typically using it in a way that is in a pretty congested environment. They're in maybe an apartment complex, or they definitely have a lot of other stuff going on their shared network. And we wanted to make sure it was as simple as possible and as reliable as possible for our customers to use. And so because of that, we created this Alexa multi-room music solution that fits all those needs. And so you can be in a pretty congested environment and you can still have many, many devices working together. When we do our testing, we test it with up to 8 devices, but we've seen groups in the field that are far, far larger than that. And we don't really put a hard limit. Of course, there's some integer limit somewhere in the system that has a limit on the number of devices that can be grouped. But from a practical purpose, there really is no limit to the number of devices that can be grouped together other than the bandwidth and capability within the home environment itself. And that is something I wanted to also reiterate, is that when Alexa multi-room music is functioning, the key requirement here is that all of the devices are on the same IP subnet and can see each other. And that's the way that they determine that they can communicate properly and create a group and keep in sync. And so that's how those things all work together. Now, I'd like to just give a nod here to that other technology path that I had mentioned earlier, which are cloud-connected speakers. Again, at the core, Amazon is always about choice. Consumer choice is key to everything that we put forward in our solutions. We're all about providing the widest number of music service providers possible, as evidenced by the fact that we now support, for example, Apple Music on our Echo family products, right? In that same kind of a vein, we aren't saying, hey, if you want to have a synchronized music experience, you have to use our technology. If, as a device maker, you have your own technology and being compatible with other Echo or Alexa devices is not a key requirement, then we enable you to implement this solution using our cloud-connected speaker APIs. And in that case, we provide a cloud-to-cloud interaction. That is to say, Alexa talks to your cloud, which then will allow you to have compelling voice control of all of the grouping and voice playback and group playback that you would have within your own system. So that's the path of cloud-connected speakers. Again, I just wanted to make sure that, as you can see here, it's a slightly different architecture. In that case, you have your Echo device or your Alexa-enabled device, and you're making a request to that device. And in the case of this particular layout, Backyard is a proprietary multi-room music solution, and that will then send the command out to the cloud of that grouping system, and then it would use the normal playback paths that have already been established through that grouping system in order to accomplish that playback. So Amazon is all about choice, so if that's your path, we've got a path for you. Not the primary focus of this slide presentation today, this webinar, but just wanted to make sure that you all were aware of that. So with that in mind, okay, hopefully at this point you have a good understanding of the way that the Alexa multi-room music technology functions and how it's different than, let's say, other multi-room music technology infrastructure playback systems. Let's look a little bit at what you need to keep in mind if you want to implement multi-room music on your own product. So what we're seeing here is the core set of requirements that are the shortest path to green, so to speak, if you want to enable your device with multi-room music. For example, Linux operating system, we've got all the infrastructure in terms of the client-side libraries and the reference code all set up for that kind of operating system environment. The target is to be an ARM v7 processor or better. And in general, we're seeing about 450 DMIPS as the required overhead. And that's for the devices that include Spotify playback within that same context. So to have the full set of music service providers, we're looking at roughly 450 DMIPS requirement. 40 megabytes of RAM are needed, around 30 megabytes of flash. So as you can see, it does require some additional resources, but it's not a huge add in terms of wanting to add this feature to your product. And then here's where the next two items are really where the rubber meets the road, because overall, we can make the system work. If you don't quite match these requirements, and we can talk to you and see if we can figure out how to make it fit, or go into a different environment. But some of the key requirements here are that because the Alexa multi-room music technology operates as a process running on the host processor, that means that the ability to synchronize across different devices is dependent on whether or not your D to A converter, your DAC, right, is actually connected through as a synchronous slave from the host processor's clock all the way down to, the way I like to say it, down to the speaker cone surface itself. And if you don't have that kind of synchronization, for example, if you have a USB connected audio with decoupled clocks, right, that is going to make it so that you don't have a common clock domain between the speaker surface and the host processor clock. And that means that because of the way we do things in the Alexa multi-room music technology, that is to say that we do the audio clock synchronization as a process running on the host processor itself, that means that you're not going to be able to keep sync, and you're not going to be able to do the audio placement as needed. So that's one key requirement here. Another key requirement that is not as harsh, but something that is important for keeping the user experience to its maximum level, is to have a low drift crystal on that host processor. Typically, we're saying that we're seeing about 10 ppm crystals. The maximum you're going to want to run is 30. Ideally, you'll have down at 2. And what that does is that ensures that you're going to have a convergence when a new group is formed as rapidly as possible. And so that's an important thing from a user's perspective, that we want to make sure that you have a low drift clock running that host processor. And if you have any questions on the follow-up of these details, please make sure you type it into the question bar at the bottom. We're glad to answer those live at the end. So now that you kind of have an idea of the requirements, let's take a little bit of a deeper dig into what a client that integrates the multi-room music technology actually looks like. So here we see a software architecture diagram at a block level that shows and focuses on the audio output capabilities that are within an Alexa client. And so here we're talking about this diagram shows a default client that is being created using our AVS device SDK. It doesn't have to use our AVS device SDK, but if you do use our AVS device SDK, we have all the patches and everything needed to make it work much cleaner. So this architecture reflects that. Even if you have your own client, though, you're going to have something probably very similar to this already implemented. And so hopefully this diagram will inform that kind of a solution. At least it's been that way to our experience so far, because the way we implemented our AVS device SDK is typically the way you'd implement a client in any case. So let's start off by looking at the blue boxes, right? So the blue boxes are indicative of the kind of client that you would get if you took our AVS device SDK off of GitHub, compiled it, and made it run on a Raspberry Pi, right? You're going to have that blue set of boxes that's going to give you the core reference standard client app. It's going to be built on top of the AVS device SDK itself. And then you're going to have the agents to handle the music. They're going to handle the speech synthesizer, which is text-to-speech. And you're going to be handling the alerts. And as those go down, they're talking to GStreamer instances that are going to drive the audio content for those different capabilities out, typically through ALSA, through a mixer, out through the hardware. And so that's what you get by default when you actually go ahead and have the base client compiled and running on your system. Now, we put into this, for completeness sake, we showed how both comms and Spotify also integrate into that client. We're not going to focus on that today very much. But the Spotify thing is interesting to notice, because if you are integrating Spotify, again, using our standard AVS device SDK, you're putting that as a third-party library that you get from Spotify directly. It's a compiled eSDK. And you would have that running and access through a patch that we would provide to you to handle the external media player functionality. That would then play that back, output PCM, go through the mixer, and then it would play out through the hardware. So you'd now have that single device Spotify playback capability added into your client. The reason why I point this out is that, as you'll see here now, if we look over to the multi-room music side of things, the MRM over there on the left, you'll see some interesting architectural ramifications of that. The first is that the multi-room music capability itself is an agent that handles what we call the cloud delegation and the focus delegation. So the cloud interactivity and the focus management that would happen for music playback through multi-room music is all taken care of in the AVS device SDK context through a patch that we provide you that then you can integrate into your client, and you're off to the races. That is what allows you on the client side to interact with a pre-compiled binary that we provide you called the MRM client library, and you receive that through the MRM SDK in a process that we'll describe in the next couple of slides. But you'll notice that that is a pre-compiled object library provided by us, and interfaces to the client through that pink colored patch that we indicated there on the top side. And then when you're talking about interfacing down to the device itself, it has three main interfaces that it uses to do so. One is a device info interface where it basically has some core IP and other information that it extracts from the operating system. The other is a time basis, and that actually most Linux operating systems can just use our default raw time interface that works sufficiently to count as the timer. If not, we have some alternative methods for you to do that time base by doing 64-bit timers. And then the most important part, the part that's the most challenging, so it'd be nicer if I had it bigger there, but it's not bigger, is the playback interface. That is where the rubber meets the road, because what happens in the MRM client library is that it's keeping time sync across the group. And then if it's the receiver, it's talking to the music service provider, and it's actually getting the content directly from the music service provider. If it's a receiver, not the master in the group, it's actually getting the content from the master device that's within the group. That is all encoded content still, and then gets fully decoded. So there's actually a full set of decoders built into this client library. So it's not, you basically take the content in, it's a black box as far as you're concerned, and then it outputs the PCM through that playback interface, and then it also outputs a timestamp. And then the trick is, and this is where the challenges of implementing MRM is, that it is up to you as the device maker to have an accurate measurement of the depth of that light purple pipeline, that is to say, the audio mixer and the audio driver. And inside that playback delegate, you need to be able to get an accurate measurement of the depth of that pipeline at the instant you're about to inject those samples into it. And then you use that through we give you some sample code of how it's done, and you use that to adjust the buffers, either by weighting or cutting them down, and then putting them into the system to make sure that it plays back in sync, again, as I mentioned, within 5,000 microseconds, not milliseconds, 5,000 microseconds of the actual required placement time for room level sync, or within 150 microseconds if you want your device to be capable of left-right stereo pairs. And so that's really where the challenge comes in terms of implementing MRM. The good news is that you'll see in our process is that we have actually defined a process that brings you along step by step through unit tests that are verifiable in such a way that you'll already have all of this code implemented for the playback delegate before you even see a copy of the MRM client library. So we give you the tools needed to do that in a much simpler environment and not have to try and build a starship out of butter knives, right? We actually kind of get you down to the bottom there before you need to worry about it. One other thing I want to mention here is that, of course, Spotify is a very popular music service provider, and in addition to be able to playing Spotify as a single device playback, people want to be able to play Spotify within a group. And in order to do that, because Spotify has a closed system that they only distribute, as everybody here is probably well aware, they distribute it as their own software developer kit with their own binary. In order to support Spotify within the multi-room music context, you actually need a second special copy of the Spotify ESDK running within the same context of the Alexa multi-room music library itself. And the reason for that is that these two systems are actually very independent. So in order to keep track of making sure that we have the right versioning information so that you can increase the version number on your Spotify ESDK as you would and keep that feature up to date according to your requirements with Spotify, but at the same time maintain the ability to have compatibility of synchronous playback across all Alexa-enabled multi-room music devices, including Spotify Playback. That allows us to fix at a specific version of the Spotify ESDK that we can then make sure ensures compatibility so that the goal, which is always Amazon's #1 goal, which is the best customer experience possible, is enabled. And so that's why you see 2 distinct copies of the Spotify ESDK in this environment. So I know it's been a long time on this slide, but as is typical, this is one of the most meatiest ones. So if you have questions on this, please don't hesitate to type them into the window. So now that you hopefully have an understanding of the requirements and you have an understanding of the high-level way the technology works, and you have a hopefully more detailed understanding of the way that the software architecture is going to work and how that relates to your hardware, how do you actually start to get on board with this? How do you actually start to use it? And so the first thing you'll want to do, and this is, again, typical with any Alexa system, is that you can go start playing with it right now. Go get a dev kit with MRM. Right now, the first one to ship with MRM enabled is the NXP IMX8 developer kit. You can go buy that, and it is already fully qualified, running with MRM. The software is there. There's an easy-to-install script. Basically, it's a no-brainer. You just get it, install it, start running, and you can pair that thing up with any Alexa multi-room music compatible system, and you can start playing with it and become familiar with the code architecture. So it's a really nice way to get your feet wet there. Once you feel like your feet are wet and you're getting familiar with it, the second thing you'll want to do is talk to your Amazon business point of contact to start get whitelisted to some of the tools and questionnaires. And as I mentioned, the key thing that you're going to want to do is we try to walk you through step by step so that you always are aware of where you're at in the process of successfully integrating multi-room music from an Alexa technology perspective. The first thing to do is we have a little questionnaire that helps you make sure that all of your requirements are in place. And essentially a slightly longer version of what was on that slide there before with some little more detailed diagram requests. But that lets us give you feedback to say, yeah, this is definitely going to work, or no, it's definitely not going to work, or yeah, do this tweak, or make sure this is in this way, and you'll be able to get it to work. And so that's what the next step in that process is all about. Once you've got that questionnaire in there and we review it, then we actually send out a request to you. If we don't already have your tool chain, we send a request for a compatible tool chain, and you would provide that again to your Amazon technical point of contact. We then use that tool chain to build a pre-qualification test suite. Now, that's important because, as I mentioned a little bit earlier, our goal is to give you as simple as a possible integration environment so that you can focus on the key challenges and know that you're going to be successful in having a product that's going to be compatible at the end of the day. And this pre-qualification test suite is the key thing that lets you get there. We give you some source code software. We give you a little binary that's been precompiled for your platform. And what that lets you do is implement this pre-qualification test suite, of which there are 6 different tests. And those 6 tests are all designed to make sure that you are going to be able to successfully implement and test your multi-room music implementation when you actually do the final integration. So the first thing we do is we make sure that your audio pipeline has a low drift rate, that 48 kilohertz really is 48 kilohertz. We make sure that your high resolution timer is sufficiently accurate, below 1 microsecond. We do a validation of GPIO. The GPIO is not used for production, so don't get nervous about that. The GPIO is simply a way of us having a reference that allows us to accurately measure the time synchronization and the audio placement, which are the 2 key things I'll talk about next. We then make sure that your device is able to accurately do time synchronization using our protocols. And so that validates that you're within zone and that your convergence is going to be fast enough. And then this 5th test, which one might argue should be the last one because it's the most important and maybe challenging, is the audio placement test. And that is where we do audio placement to make sure that you're within the 5,000 microsecond or 150 microsecond range. And then the final thing is we do audio distribution, making sure that your network path is sufficiently fat to be able to handle the bandwidth that's required. We talk a little bit about, and since I want to make sure I have time for questions, I'm not going to go into this in too much detail. But when you do the pre-qualification tests, you receive some instructions along with some Those instructions are specifically including some hardware you'll need. You'll need 2 devices of your own. You'll need to have 2 echo dots. You're going to need to have your tool chain as a digitizer we specify and a logic analyzer. So these equipment are actually what we specify that allow you to be able to run these tests and get those accurate measurements in place. And so, for example, the first test is the audio pipeline drift test, where you take your device and you hook it up to an audio digitizer, and that audio digitizer then is going to sample the audio accurately, running in this case Audacity, and we do some calculations based on the samples to make sure that when you're playing 48 kilohertz that you're actually generating 48 kilohertz, for example. And the good news is that if you're got some drift in there, we can actually adjust for it. So the output of these tests is twofold. One is to make sure that you have the capabilities that are needed, but the other is to, if your device has some unique characteristics, we can profile those characteristics, and then those characteristics can be used in your implementation in such a way that will allow you to have perfect placement. And so that's one of the other reasons why we do this testing. So once you've passed the pre-qualification test suite, you're pretty much golden. We will go ahead and deliver to you the multi-room music SDK, which has the binary MRM library that's compiled for your target platform. And then we provide you with these what we call key performance indicator and functional test suites. And those are actually the same tests that we run internally when we're validating your product. So you have the exact same tests that you can run internally, and before that device ever shows up here, you're going to know that you're going to pass. So you go ahead and you do the integration. You're able to take some of the code that you created for that pre-qualification test suite, you drop it into your integration to implement the playback handler, and you run through these KPI tests, and hopefully within 1 or 2 sprints, you're ready to go. And so that is going to basically give you the confidence that you've tested the device, you see it passing, so that when it shows up in our facility for incremental testing, that is, we do MRM, it's actually an incremental test on top of your regular Alexa certification testing, you'll be ready to go and it'll be all set and you're passed and you're ready to launch. And to give you an example of this, the first product we had out the door was the Polk audio command bar. There were, as you can imagine, some consumer desire and complaints before that feature was rolled out. And once it was rolled out, people were super thrilled. And they were like, yeah, we finally have this capability to group our command bars and play them with other Alexa devices. And so that was really exciting to see. So to kind of wrap things up here, if you have your next steps and you want to move on, and this is a technology that interests you, you can go ahead and get a list at these URLs of the different solutions providers that have MRM experience, and that list is growing every day. You can also go and get a dev kit that has MRM enabled inside of it. I already mentioned the NXP IMX8 dev kit that's ready to go. We have other ones that are very close to shipping and qualified with that, so keep an eye on that URL. You can ask your Amazon point of contact for additional access to the resources we mentioned earlier, and just jump in and start making it happen. And we're here to support you as we can, because we're really excited for this feature to roll out to all of your customers, and we hope that you are too. So with that, I'll turn it back over to Fletch, who I think is going to go through some of the questions that we've been accumulating over the time here.
Thanks very much, Dave. That was a great webinar. Hope everybody can hear me okay, and sorry for the earlier microphone quality. We have a whole bunch of really great questions, so we're just going to go through and fire off rapid fire as many as we can. A couple of questions came through about Alexa Connected Speaker API implementation. Jawad and a couple other people were asking, for example, could they use Alexa devices as additional speakers to their Sonos system? Can you comment on a little clarification, some examples of Connected Speaker API?
Yeah, so while I don't want to comment specifically about other people's implementations, because obviously people wouldn't like me commenting on theirs in public either, in that particular case, you're looking at a So anytime you use a connected speaker API that is not using Alexa multi-room music technology, I'm sorry to say that as of today, those things are not able to be put into the same group. But if I do have, for example, a Sonos One with a number of other Sonos devices, or another kind of device that has its own multi-room music capability, and then I have, let's say, some other devices like a Polk command bar, and then I have some Echoes, and I have those grouped together, all of those can coexist in the same home and in the same environment. And you can even, say to one, let's say your Sonos is named downstairs, you say play it downstairs. And let's say your Alexa multi-room music is living room, you can say play in the living room. All of that will work and it will be fine. It's just that those groups can't be grouped together.
Great. Okay, a couple questions on the sender versus the receiver. On which criteria does Alexa select which device will be the sender? Pierre from Orange and John also had some questions from DigiSpeaker. For example, does MRM prioritize a Ethernet connected device as the MRM sender?
So that's one thing we don't, it's as far as the algorithm for that, we typically don't comment on exactly how that is being selected right now. It's a heuristic that is being implemented inside the Alexa cloud itself. There are a number of different criteria that we use to assign the sender in that case. And, one could imagine that, the capabilities of the connectivity or the reliability of that connectivity could be one. There are a number of different factors that are used to actually pick that sender. It's a totally, it happens within the cloud and it happens within the context of the MRM device itself. And actually that algorithm is evolving over time. So it wouldn't be accurate to say it's going to be one way or the other.
Great answer. Thank you. One question that both John and Dragomir had is, can they play multi-room music from different sources, not necessarily a streaming HTTP URL from a MSP, but they're thinking, for example, accessing local media files on a private media server. Is that possible with MRM?
Today, that is not possible. We are aware of that as a feature, desired feature. You could also imagine that line in, right, is also an interesting feature. So we are aware of that, and today that is not the case.
Thank you. There's a couple questions about MRM patch. Does that only work with the latest AVS SDK, or is there some compatibility with earlier versions?
So it depends on how far back you want to go. There is a limit, and that's true of all of our patches that we put forward. Ideally, you're using the most recent version of the AVS device SDK because that's the version against which all of our patches are QA'd. But if you have a version that is older and you're having trouble using the patch with that version that's older, please do not hesitate to contact your Alexa Solutions architect, and that person can make sure that your question will either be answered directly or they can get your question answered by the right people.
Great. Amaya from Qualcomm had an interesting question. They were wondering if you provide the MRM client library for Raspberry Pi, and if not, there may be an interesting technical reason why not. Could you quickly explain that?
So we do make that available to developers who need it for some of their testing and evaluation. We aren't broadly distributing that, but we do have it available. To date, just to be specific, if you were to take that library and you were to run it on a stock Pi 3B, it actually wouldn't pass our pre-qualification tests. And the reason for that is that the stock 3B uses a USB-based audio path on it. But if you put a DAC hat on it, like a fat DAC or something like that, it will work nicely and actually has pretty darn good placement. So if that's a path that you really want to pursue in terms of your experimentation, we're open to that and you can use it. But if you want a turnkey solution, we have some of these reference designs that are turnkey. Like I said, there are other vendors that are coming along that all have their reference designs, and as far as I'm aware, a good number of them are integrating and making MRM as capable on their reference designs.
Got it. There's a couple technical questions here about specific specs. For example, Scott from Surface Inc. had a question about the low drift oscillator spec. Is there a place in that resources link that we could point them to in order to get those app notes or whatever? Where would they find all that information for their reference?
So that information is in that questionnaire that is made available to the device maker once they've made the contact through their Amazon technical contact. The specific thing, if people are curious, they ask for app note 0006, and that will be the thing that they're looking for. So
nice. Not to be confused with 0006.
Exactly, because that's a totally different app note. You know.
Here's an interesting question from David at Symmetric Designs. I like this one because it's thinking of the customer experiences. David wants to know: is there or will there be a way to balance the volume of multiple devices, i.e., volume 5 is not the same level across all devices?
So that is a very astute observation. Who clearly extra credit. If I had extra credit, I'd send it to that person right now. That is a big challenge, actually. And right now, that's something that is not something that is easily resolved in terms of what we are shipping today. But we are aware of that as a challenge.
Okay. One question from Jeff at Logitech UE. Is the unicast stream recompressed at lower bit rates than the native stream? And then follow-up question on that. What bit rates or formats are supported, for example, lossless?
So that's a good question, because apparently I wasn't clear enough on this. We actually use the source stream. We don't decode it to baseband and then re-encode it. We leave it there in its original source when it gets redistributed. So you're not getting any transcode artifacts in that. Now, there may be cases in the future where we decide there might be topologies in future releases where we might need to do that. But the way things are working in the current system is that everything is left in its encoded form before it's redistributed. So you don't get any transcode artifacts. And so to answer the second part of that question, by implication, that means any format that is supported by any music service provider that is enabled by Alexa is passed through in the multi-room music capability from Alexa.
Great. Thanks for the detail on that. Mech had a question from Viasat. This is going back to those kind of customer scenarios. Can a device be added to multiple groups? For example, if they want an Echo device to be part of the living room group as well as the everywhere group?
So that originally was not the case back in August of 2017 when it first released, but that is the case today. So yes, you can have devices be part of multiple groups today.
Got it. Okay. Another question from John. Does Audacity need to be running on Mac for some of our pre-qual tests? If he can run it on Linux, is that all right?
So the short answer is yes, you can do it on Linux. The long answer is all of our scripts have been QA'd and everything's set up and thought of being running on Macs. But if you want to do it on a Linux platform, we have no requirement as far as that's concerned. It's just that the tools we provide are essentially debugged for a standard Mac environment.
Got it. Okay. One more deep technical question from John. Is time standard IEEE 1588?
No. So the time synchronization is our own time synchronization methodology.
Thanks. One question from Eric. The MRM API has a way for a receiver to report their latency. Can you talk a little bit more about this works? Like how much latency can MRM accommodate?
So with regards to the latency itself, it's pretty significant, the latency that can be accommodated. We have not yet run into. So number one, there's no hard limit, right? The hard limit would be the buffer size, essentially. The practical limits, we have not encountered any architectures that go beyond the latency capabilities of multi-room music so far.
Got it. And that number you mentioned earlier, that 150 microseconds synchronization, is that a target mid-band value, or is there a number at which the customer experience would be impacted?
So those are two different ideas. So latency is Just like people who are listening to this broadcast right now are actually hearing us 10 seconds after we speak. So that's the latency. The synchronization, which is what I mentioned before, is the 150 microseconds for left-right stereo or 5,000 microseconds for room-level sync. That is the time slippage in between which the different devices are actually producing the same sample on their speaker surface. So everybody could be latent by, 10 seconds. I mean, that'd be weird, but everybody could be really latent, right? But as long as they're all in sync, that's what counts.
Got it.
And
Okay.
sync is different than latency.
Got it. Okay. One more question from Eric. What happens when to an MRM group if a member of the group were to come and go? Say something got disconnected or plugged in or lost its internet connection or power while music was being streamed?
If it is a receiver, there's no impact. If it's the time master, because there's actually a time master and a content sender, and those are typically two different things. If it's the time master, there's a new one elected. If there's a content master, sometimes if it's a track by track delivery service, let's say it's Amazon Music or another one, it could actually pick a new content master in time where you wouldn't notice. If it hit at a certain time where the buffers weren't in the right spot, you might hear a hiccup and then it'll recover. But that's part of the topology relayout that happens in real time when you lose one of the devices.
Got it. One question regarding two speakers to create a family room. Is it possible to create a group of just a single speaker? And are there any timing considerations that you have to think about between two or more speakers in a group versus just a single speaker in a group?
Well, a single speaker is, if I'm understanding the question correctly, a single speaker is not actually a group. It's a targeted named device playback. So if I have one device and I want to target it, I simply give it a name in the Alexa companion app, and I just say, play the Beatles on this device, and it will play on that device, and the synchronization is not something that needs to be concerned about. But if I have two devices in the same room, which is one of the core functions we're talking about, if I want them to be playing the same content, but they're not trying to be a stereo pair, they can be within 5,000 microseconds of each other, and that's their core requirement, which is a fairly straightforward thing to achieve we've seen so far. But if they want to be left-right stereo pairs, they need to be down to 150 microseconds, and that means that one is playing the left channel, one's playing the right channel. You want the stereo image to be rock solid right in the middle of them and not drift around at all. That means you need to be down to that 150 microseconds.
Okay. Quick question from Sonia. We've just got time for a couple more questions here. How long can music play on all the connected devices in MRM? Is there some sort of buffer or some sort of limit?
No, there's no real limit on that. It's basically, think about it as like a virtual wire. As long as now music service providers themselves might have a timeout. Like I know that some providers will time out after a certain number of hours, but that's the provider level, and that happens on a single device. It's not an MRM specific thing.
Got it. We had one good question about you mentioning Spotify ESDK integration, and I think Spotify is a special case in many ways. What about other music services support? Is there additional hoops that they're going to have to jump through to enable MRM, or will MRM simply not work with some additional MSPs? What do they need to know?
The good news is that the complete content path from the music service provider all the way down to PCM is handled within the MRM context separately. So it's the job of the MRM SDK itself to worry about that MSP compatibility. So in short, all MSPs are supported through MRM, which by the way is one thing we didn't talk about, which is that part of the badging requirements for MRM are that you need to have support for all of the MSPs in your region. And that's actually the specific reason why you do that, is because it'd be really odd if the single device playback didn't support an MSP, but MRM did. And so because MRM is being deployed as a technology across all of Alexa products, by definition, it supports all of the music service providers.
Great. Well, I think we're going to have to end it there, but I want to thank everybody for attending today, and big thanks to Dave Frerichs for that excellent webinar and the in-depth answers to all the questions. Just a reminder to everyone, we're going to be sending out a recording of this, and we'll follow up via email on that. Thanks everyone for your questions, and stay tuned. If you are signed up for voicemail at developer.amazon.com, you'll be the first to know when the next webinars are happening. Thanks everybody very much.
Thank you.